All right, today we're going to talk about something kind of radical. It's a new idea that could make everything, I mean your phone, the cloud, everything, run smarter, faster, and way more efficiently. It's called information transform compression, or ITC for short. Think of it as a brand new universal language for our tech, all built around one simple principle: efficiency.
So let's just dive right in. I mean, think about it. We love our powerful apps, our super smart AI, but have you ever really stopped to think about the hidden cost? The insane amount of energy it all uses, the constant need for bigger and faster hardware? It's a lot. So what is going on here? Why is our digital world, especially AI, just so incredibly power hungry?
Well, the short answer is digital bloat. We build these amazingly complex systems, but we tend to treat every single part of them as if it's equally important. You know, it's like using a sledgehammer to crack a nut. This one-size-fits-all way of doing things is just incredibly wasteful, and honestly, it's holding us back from what our technology could really do.
So let's zoom in on the biggest offender right now: artificial intelligence. AI models have gotten absolutely gigantic, and the way we've been trying to shrink them down to fit on our devices, well, it's just fundamentally flawed.
Okay, and this slide. I love this analogy because it just makes perfect sense. The old way, what we call uniform compression, is like taking a beautiful high-res photo and just shrinking the whole thing down. Yeah, it's smaller, but you lose detail everywhere, and pretty soon you can't even tell who's in the picture. Now, the smarter way, this new adaptive approach, is totally different. It's like a great photo editor who knows the faces are what's important. They keep the faces crystal clear but blur out the less important background. You save a ton of space, but you keep what actually matters.
So the big question is, how do you teach a computer to be that smart photo editor? How does it figure out which parts of an AI are the face and which parts are just the background? Well, that requires a whole new way to measure what's important.
And this, right here, this is the breakthrough. The researchers came up with something they call the information density metric, or IDM. You can literally think of it as a universal importance score. For any little piece of a complex system, the IDM spits out a single number that says, hey, this part is absolutely critical, leave it alone. Or, this part over here, it's not so important. We can shrink it down a lot.
So how does this magic work? Well, the IDM looks at three key things. First, entropy, which is really just a fancy way of asking how complex and diverse is this part. Second, sensitivity. How much does messing with this part change the final answer? And third, redundancy. How much of this is just, useless, repetitive information? It combines all three of these into that one powerful score that gives it a perfect picture of what truly matters.
And this quote from the research paper, it just nails it. The entire system is built on this one simple, powerful truth. For years, we basically treated our AI models like every single part was sacred. But the reality is, some parts are doing all the heavy lifting, while others are pretty much just along for the ride.
Okay, let's get practical. Look at this real-world example from the research. Check out those IDM scores. The fully connected layer has a score that is way, way higher than the others, like hundreds of times higher. So what does the system do? It gives that important layer 8 bits of precision, lots of detail. But the other layers? Their scores are so low, it knows they can be compressed aggressively, all the way down to just 1 bit. That's targeted intelligent compression in action. It's beautiful.
But, talk is cheap, right? Does this fancy theory actually work in the real world? Let's get to the results, because the numbers, they're absolutely staggering.
On a standard AI model, they got almost 16 times compression. Just let that sink in for a second. A model that used to take up 16 gigabytes of space could now fit into just 1. This is an absolute game changer for getting powerful AI to run on small, everyday devices like your phone. It makes private personal AI a real possibility. But here's the part that really blew my mind. All that shrinking came with less than a 3% drop in accuracy. So you're getting these massive, massive gains in efficiency without really sacrificing performance. It's pretty much the best of both worlds.
And this chart just tells the whole story, doesn't it? The old methods, they top out at around 4x, maybe 8x compression if you're lucky, before the AI starts to really break down. ITC, with its smart, adaptive approach, just blows right past them. It achieves basically double the compression of even the most aggressive old-school methods. It's not even close.
Okay, so shrinking AI is a huge deal. But this is where the story goes from being a great invention to a full-blown revolution.
The researchers realized that this core idea, measuring the value of information, isn't just for AI. It's a universal principle.
So what if? What if we could apply this same logic to everything? I'm talking about the software on our computers, the data in our databases, even the information flying across the internet. What if we could teach our entire digital world to stop wasting so much energy on the stuff that just doesn't matter?
I mean, this is the grand vision. The very same information density metric that shrinks AI models could be used to compress a C++ program by figuring out which functions are critical. It could make databases way smaller by understanding which data is accessed the most. The possibilities, they are literally everywhere.
You see, it's about a fundamental shift in how we think. We need to stop seeing computation as just running lines of code. Instead, we need to see it for what it really is, a process of transforming information. And once you see it that way, you realize you can start optimizing the information itself, not just the instructions.
And all of this points to a pretty radical new vision for the future of computing, building systems that are, from the ground up, information aware.
And they've got a clear roadmap to get us there. Phase 1, proving this on AI? Check. That's already happening. The next step is to build tools that can apply this stuff to regular software and data. But the ultimate goal, Phase 3, is a universal layer that just optimizes everything automatically, all based on the principles of information.
And this really shows you how big of a shift we're talking about. Today's computers, they just blindly follow instructions, line by line. They have to fully decompress a huge file just to look at one little piece of it. An information-aware system would be completely different. It would understand the meaning of a program. It could work directly on compressed data, and it would probably run on totally new hardware, specialized chips called information processing units, or IPUs.
And why does all this matter? I mean, beyond just having faster apps, the real-world impact is enormous. We're talking huge reductions in storage costs, in energy consumption, in network traffic. This isn't just about convenience, it's about building a digital world that is fundamentally more sustainable for everyone.
This quote from their vision paper just says it all perfectly. This is about moving towards systems that don't just compute faster, but compute smarter, guided by the very laws of information itself.
So, I'll leave you with this final thought. For pretty much the entire history of computing, we've focused on teaching machines how to follow our instructions. But now, it looks like we're on the verge of teaching them to understand value, to know what's vital from what isn't. And if we can actually pull that off, what new frontiers does that unlock? What could we build that we can't even begin to imagine today?